Welcome. This is Coach Dorf. We're in section 4.2 and we're looking at this homework example. In this example, we notice that f is continuous on the closed interval from 0 to 4. So f is continuous on closed interval from 0 to 4. It also says that the derivative of f is between 2 and 5 for all x on the open interval from 0 to 4. That's another way of saying that f is differentiable on the open interval from 0 to 4, and it has the property that its values are between 2 and 5. Well, what's true about these two conditions? Well, these are the hypotheses of mean value theorem. So we can use the mean value theorem in this problem. What's the conclusion of the mean value theorem? Well, it says that there is a number c where c is between a and b such that the derivative of the function at c equals f of b minus f of a over b minus a. All right, so let's look at this. What's my b and my a in this problem? So notice in this problem, a is 0 and b is 4. And that comes from the fact that I've got these right here. That's where I get those from. All right, so what is then f of b minus f of a over b minus a? So that's going to be f of 4 minus f of 0 over 4 minus 0. Now we're given in the problem that here that f of 0 is 1. So this equals 1. So I can rewrite what I have here as f of 4 minus 1 over 4. All right. We also know that this, so by the mean value theorem, we're going to get that f of b minus f of a over b minus a is going to equal the derivative at c. So we can take these two parts, this part, and they have to be equal to each other. So in other words, that says there's a c value such that prime of c is going to equal f of 4 minus 1 over 4. Okay, from here then, remember what we're trying to do is we're trying to show that f of 4 is between 9 and 21. Well, let's isolate f of 4 by itself. Let's get this f of 4 by itself. So I'm going to multiply both sides by 4. So I'm going to get 4 f prime of c is going to equal f of 4 minus 1. And I'm going to add 4 to both sides to get this. Okay, I now know that f of 4 is between, f of 4 equals 4 times f prime of c plus 1. Well, what's the smallest f of c can be? Well, going back to the very beginning, it says that, recall that on the interval from 0 to 4, f of c, smallest it can be is 2, f prime of x, and the largest it can be is 5. So if I take what we have here, right, what's the smallest f of 4 could be? Well, if I plug in this, if I substitute in this 2 here for this f prime of c, what do I get? I get 4 times 2 plus 1, and that's going to be 9. That's the smallest value f of 4. Where does the f of 4 come from? It comes from this part right here. What's the largest it could be? Well, if I took this value and put it in there, I'm going to get 4 times 5 plus 1, which equals 21, and that's the largest value for f of 4. How do I know it's the largest? Because the 5 is the largest, and how do I know that so that's the largest. How do I know that the red number 9 is the smallest? And that's because we used the smallest f prime value, which was 2. So all this stuff together then means that the smallest f of 4 could be is 9, and the largest it could be is 21, and that's what we were supposed to show. All right, so again, what's the key idea here? I noticed at the very beginning, because f is continuous and because f is differentiable on that interval, I can use the mean value theorem. So I apply the mean value theorem, substitute in the numbers, and then I solve for f of 4 and then work to get my result. Hope that helps. Thanks.